a little definitely charity looking. Oh, but I'm not sure. Oh, maybe that's what opaline. Anyone opaline? Is opaline about?
Yeah, yeah. You'll see a lot more. It's always. I'm just trying to gather people because we've all.
Kind of looks like they might have done some exploration.
Got a road.
This is what I call the lower terrace, where material has been cut down from where it's working. But I'm just pausing. I was pausing here to let people catch up. But like yesterday, you can see where fluids are starting to push out between, in the existing pillow lava, and here it's getting altered to that epidote we saw yesterday. But then when we come up into the area where the people at the front have come to, you can see these are blocks that have been pushed down from this upper terrace, and this has got a lot more of the actual opal in it. But
Are they mining? Are they just mining the opal?
I think it's artisanal. There's lots of copper here as well. Yeah, I mean, I think it's been mined for,
So we see and some red colored minerals. And look at how it does on my wow, it's making pink. I don't think I'll take it home though.
no, it won't last.
It's too big. Oh, there's also some here.
So yesterday we saw a black smoker, which is about 300 degrees, and a sulfide system. Today we're looking at a white smoker, so this is about 150 degrees C. So less high temperature and silica and opaline instead of the sulfides, but there's plenty of mineralization. And it forces its way through and brecciates the rock. So these are hydrothermal deposits forced into the pre-existing basaltic rocks.
Times unit again, but actually it's felsic here. It's actually an andesite, and this is the geotimes unit. But then the sheeted dike complex starts just there. Those are actually sheeted dikes, and this is marking it on the geological map. This is where the sheeted dikes sort of give way to the units above, and it's just there, according to this map. But what we're going to see here is a sort of little bit of everything. You've got lots of pillow basalts, and already you can see the sort of pistachio green colour of the alteration between the basalts from here. You've got some columnar cooling up there, and you've got a columnar cooling that's fallen down as a block on the ground. You've got various dikes coming up, and actually this is also a site where copper smelting happened. I'm not sure what age it was, but we find slag here from copper smelting. So there's a whole multitude of things going on here, and basically walk that way towards the blue plastic, and we're going to go and have a look at those pillows and those dikes and that columnar cooling, which I don't know if it's coming as some kind of sill. I mean, why that would be there, but obviously we're going to have a closer look at it. Okay.
Yeah.
So
so here's some columnar basalt. And then there's some up on the hillside as well. And then these are pillow lavas.
feeder dikes into.
So these basaltic columns are slow cooling, and it looks like they may have come from way up there. So this block makes it easy to touch. Need my phone?
That looks like sort of like a tail.
got some green iron-bearing material here that I think they mined for copper.
In the handout is just something that I have drawn myself, and it's my interpretation of the scene. But if you turn facing, you're going to face forwards, but for just a second face back, and behind us is all mantle rock. And you can see here on the left, it's all the mantle. This is Hartsbergite and Dunite. This is the Semile ophiolite nap. It's the very base of it. And then down at river level, this is the metamorphic sol, and we're going to stop around there to actually have a look at metamorphic sol. Now, you don't know what the metamorphic sol is yet, but I will explain in a bit. And then on the other side of the river, this is volcanic rock, and this is on a different nap. This is the Haby nap. And it's volcanic rock at the base with marble at the top. And these are volcanic islands with coral reefs on top, which are atolls that have got jammed in the subduction zone. And then looking around the corner, so basically that nap is coming over the top of us. So we plunge underneath it. It itself plunges underneath the background back there. And the highest mountains you can see, and then the level down below it a bit, these are, there's folds all in it. These were the Horwesina nap, and these were turbidites. So these are where you've had sediment building up on the continental slope, and then they've slumped down into the ocean basin, and layer upon layer they've built up these deposits. And what happened when the ophiolite was in place, if you imagine, the plate is my hand is the ophiolite, the plate has been dragging under. As it's dragging under for 20 million years, all on the plate there were volcanic islands, and they were getting stuck in the subduction zone, and then behind them is all the turbidites that were lying on this ocean plain, and they've all been, they haven't wanted to go down the subduction zone, and they've all been folded and crumpled up, and they've slid themselves over Arabia. Well, they've slid. This has gone over Arabia, but these two naps have gone over this. If you see what I mean.
So what is the white one out there?
Are the slope?
No, they're
Turbidites are in the background.
the Havasina is over there.
Way over there.
See all these curves there.
Yeah.
Oh.
Now, if you look at the diagram on the top of page 25, this reconstructs it before the collision happened, and we are standing just on the plate boundary, just here, where the orange, with its purple underneath it, meets the green and the red, and we're standing just there. And as things have gone along, this atoll here has got scraped onto the top, and all these sediments have got scraped onto the top of it. But this has all gone onto the basement.
So what is the light-colored mountain? Is that
the light-colored mountain is marble that was once a coral reef.
Oh.
Right.
But that's also a reef over there sticking up the mountain.
No, that is sediments that were the Horwesina nap, which were once turbidites, and they've been scrunched and folded up.
Now, I understand your question. Is that the turbidite or in the distance? Distance.
And so this one here, though, is that?
We're going over that, and that is going over the Horwesina. I hope I didn't say we were going under it. You can see with the arrows that the Horwesina's, the ophiolite's going on top of the coral reefs. Coral reefs are going on top of the Horwesina, and the Horwesina is going on the continent. So who hasn't been to the toilet?
But this was a complicated spot. I think we need to read the.
Here we are in Oman, and this is an extraordinary view. We're actually seeing 3 different naps. We are standing on the nap, which is the Samail ophiolite. This is the rock that was the mantle and the ocean crust, and it is going over the top of everything else we see in front of us. Well, what are we seeing in front of us? We are actually seeing volcanic rock from the Permian and Triassic, which is capped with marble. Now, this volcanic rock capped with marble, these were actually atolls, volcanic islands with coral reefs, and this was a subduction zone. And as this was going over the top, or more accurately, that was being dragged under, these atolls were getting wedged in the hinge of this subduction zone. But that is not all. Both units are actually have been moved over the top of the back mountains as they've also been coming underneath us. And they were, that was the ocean floor, which was some hundreds of kilometers away from the Arabian continent we were, and a whole ocean floor covered in turbidite sediments. And as this was diving underneath these 2 units, all of these sediments were getting scrunched up and folded. And one further bit of detail, welded onto the bottom of this is metamorphic rock known as the metamorphic sol, and that got metamorphosed as subduction was ongoing. And dating that metamorphic sol, it's exactly the same age as all the ophiolitic rock, which is further proof that this ophiolite had to have formed above a subduction zone. Right now, I think we do. We're going to talk about the metamorphic sol at the next. So the metamorphic sol is not a restaurant. It's not. When the subduction was initiating and going underneath the ophiolite, what would happen is the rock that's going down the subduction zone would get heated by the mantle wedge that's going into it. And it's heated from the top rather from the bottom, because its bottom was the cool slab, but its top was exposed to the mantle, and it was getting turned into metamorphic rock. The stuff that went really deep got turned into amphibolite. The stuff that didn't go so deep got turned to green schist. This didn't go so deep. It only got turned to green schist, but it's our story. We're getting to see the metamorphic sol. But once things are all getting scrunched up and not going down the subduction zone, this metamorphic sol got welded onto the base of the ophiolite, and it's ridden with the ophiolite over these volcanic islands and atolls, and they've all ridden over the sediments, and all of that has ridden over the Arabian margin. And this metamorphic sol is a key bit of evidence that this ophiolite formed above a subduction zone, because the metamorphic sol is exactly the same age as all the pillow basalts. Now, one further complication to all of this is later on in the trip, on the last day, we're going to encounter eclogites and blue schists. Now, those are actually 20 million years younger than this metamorphic sol, because they got formed once the continental margin was going down the subduction zone, whereas this metamorphic sol is the age of the ophiolite. It's when the oceanic crust was, just starting to go down the subduction zone. So both of those different stories formed in the subduction zone, but this is exactly the same age as the ophiolite. Okay. Some more talking over there. This top is amazing. You can see the ophiolite behind us. You can see that's clearly the mantle. That's coming directly over us. You can see the Horvacinas that way. You can see the folds and the turbidites. We're on the sort of the boundary of the Haby and the metamorphic sol. Now, this is all Haby. This is you've got the volcanic, you've got the atoll, but also you've got these radiolarian cherts as well, which these are deep water sediments, and there must be some sort of thrust between them and the shallower water atoll, but they're all on the same nap. And what a radiolarian chert is a type of plankton that's rich in silica. And in the deep oceans, they're living there, and they will rain down to the bottom of the ocean, and they can start to get preserved in conditions which are too deep for calcium carbonate to be preserved. So when you see these radiolarian cherts, you know it's a deep water environment. So that's what this red colour is, and that might be off-putting you. But it's all part of a stop. But this outcrop directly behind, this I believe is what the guidebook says is the metamorphic soul. And then when I first came here, because you've got you know, metamorphic soul described in other locations as being granulite or up to amphibole you know, fascies, I found this confusing because it's like, gosh, this clearly isn't that high grade. And then I realized, well, it isn't that high grade because some of the metamorphic soul, you know, isn't as high grade. And this is an example of it not being as high grade. There are places in Oman where you can see it very, very high grade, but they're just not on a geographically located in a place that would be convenient for this trip. They'd be too far to drive. But let's come across and have a look at this metamorphic soil. The experts in the group say, oh, I don't think that's what it is, but it's what the guidebook says it is, and I think this is metamorphic rock, but it's green schist fascies rather than amphibite fascies. And this is what this probably is actually some of these cherts that got dragged down the subduction zone and they got changed into this metamorphic rock. But looking here, it's I think you can see it's very, very folded and contorted. They've got green colours to it. Well, now let's there's actually two ideas how the metamorphic soul forms, and I put both of them in the handout. And the reason why I put both in the handout is because the guidebook talks about the old idea. Now, if we go to the old idea first of all, the old idea was that the ophiolite was a spreading ridge, and when the compression started, this side thrust over the top, and when the other plate was thrusting over the top, because its base was hot, it had what they call the ironing effect, and it came over and it cooked and metamorphosed what it was going over. And that's the original model. But when people started to realize, no, the ophiolites formed over a subduction zone, a new model has been formed. Because if that ironing effect was true, then the metamorphic soul wouldn't be the same age as the ophiolite. It would be younger. But the metamorphic soul has been dated to be exactly the same age as the pillow basalts. So it's and the bonatites. I mean, it's the same age as the boninites.
Yeah.
So this would be the crissionary cone that has been pulled over as a result of
Pulled down.
Pulled down.
And then metamorphosed.
Yep.
Right.
Down.
Now I'm getting it.
Yeah. And what it's been metamorphosed, one of the key ideas is when it was being metamorphosed, is actually when you're looking at the soul, it's more metamorphosed at kind of its surface than deeper down, if you see what I mean. And that's because it was getting more metamorphosed from above. It was now sticking into the mantle, and it was getting metamorphosed from above. And if you look at this diagram on page 6, you can see that some of the metamorphic soul is just coloured green and some is coloured purple. And the purple has gone down deeper, and what's coloured green hasn't gone down as deep. And this would be an example of not gone down as deep, but it's still part of the metamorphic soul. I mean, have you seen it all really foliated? And yeah. I mean, would you agree that that's a metamorphic rock?
Oh, of course.
Of course, yes.
Right.
Good.
And the fact that it has foliation tells you that that's being defined by clady minerals.
Yes.
So chlorites, biotites.
But what that means
There's a little
is
bit of white mica in here too.
Yeah, and for the model, that means this is stuck onto the base of the ophiolite there, and that means the kind of the plate boundary, we walked across it between us and the cars. You know, because that's the other nap over there. So this is coming, it's curving around how it's coming over, but which is really extraordinary.
So we're at Wadi Ad Dil. It's stop number 4, and on day 4, and we are looking at the metamorphic soul.
Right, we're going to have to end this party in a...
So we're day 4, stop 4, Wadi Ad Dil, the metamorphic soul. So this is a place where we're going to see 3 stacked thrust sheets. So the first thrust sheet is behind us. That is the Samal ophiolites. And at the base of the Samal ophiolites, we're going to have a close look at it. That is the metamorphic soul. And here what we're seeing is that it's green schist. So it has been dragged down, abducted, and it's been, the micas are very reflective and foliated. So as we continue to look to the west, there's a slice, the Samal ophiolite, and this plate boundary has another plate. This plate is a Triassic reef that's sitting on volcanics that has been caught up in slivers, and it is plate number 2 or slice number 2. And as we look over here, there is some more of the metamorphic material, and then as we come this way, we're seeing radiolarian chert. That's at the top of the ophiolitic sequence, and as we continue to pan this way, this is all part of turbidite. There's turbidites in the distance, so this is then thrust over the turbidites of the Hawasina. So we have major thrust sheets here that have been dragged down in abduction, and in the distance it's really folded. The radiolarian church. At our last day, we're going to see the mother of all outcrops, which is a bunch of really folded radiolarian cherts, and we're going to get a preview of that at our next stop.
The thrust fault from down there, and we're on the next nap. So the atoll coming over us, and then the mantle, the ophiolite with its metamorphic soul over that as well. And all of these sediments, these were, this is the Hawasina nap, and these you would have had on the margin of Arabia, rivers bringing down sediments and putting them on the continental shelf, and where the continental slope was, sediments would build up and then they would slump down this slope, and what we know is turbidites, and spreading out as fans over the ocean basin. And you would have repeated cycles of these where a layer comes down in its course and it finds up, and then another one comes down in its course and it finds up. These are known as boomer sequences. And then when this whole emplacement of the ophiolite happened, all these sediments that were horizontal, they had been scrunched up, something chronic. And look at them, they're all folded and scrunched up, not wanting to be being subducted, and they are this nap that slid over. And what we're seeing when we're looking at these beds is the harder, more competent layers, the sort of sandstone units are at the bottom of these boomer sequences, and it finds up. And by looking at finding up, you're going to be able to tell which way up these folds are. But anyway, it's also just eye candy as well. It's just beautiful to see these folds.
So these are boomer sequences, turbidites, and they're folded.
Right side up, that might be.
What we'll soon be going. from fine grained sand right into Dale intermediate stuff, which is not waiting for the last car to come. I'll tell the people who are here what this is all about. Right, I don't have a very big explanation. Basically, lunch is going to be down below, and where the cars turned, where that triangular sign is, on the left there's a footpath that comes down, and they're directly behind us setting up the lunch. And while they're setting up lunch, let's spend some time having a look at these wonderful folds, and there's faults, there's various faults to see, and this is all part of the whole Racina nap that we stopped at before. I think it's shallower water than the stop before, but it's just.
So these are Jurassic in age.
And okay, so Permo-Triassic rifting, sediments filling up open ocean, it gets deeper, turbidites. So the Hawasina phase is the earlier ocean opening phase that then gets thrust later. It's not part of the later thrust phase where there's you're closing the ocean. Am I thinking about that right? Because
I believe that to be right, but I'm not certain. Yes.
I'm trying to make it. But think about it. This rush is very different. This Samal rush is all the ophiolites. Yes. This is none of that. Yes. This is all the sediments before that. So one big sheet of the depth of center, and then one big sheet of the closure.
Here's a great chevron fold.
Nice sort of thrust fault.
So there's a thrust fault.
yeah.
How do you call it in English? That
Thrust
fault?
fault. Well, I think the whole nap is going to be riddled with thrust faults.
So one is being thrust over the other.
Yes, yes.
You've got sequences. The turbidites come down, its course it gets finer. The next one comes, its course it gets finer. The next one.
And this is the final.
This is the base course, I think. This is the base of the course one.
Wow.
So, James.
Yes.
These are extraordinary flutes and grooves.
Okay, I'll come and have a look.
And you know how that momentary earth. This is a current eddy, and it scours.
Scours in.
And so the current direction is
so
this
we're
way.
kind of inside the rock here, and the surface is away from us.
This is the bedding plane.
Yeah.
And the current is going this way.
Right.
That way, yeah. And that's the bottom of the bed.
But yeah, this is the bottom of the bed, so it's upside down. Yeah.
Yeah. And that often happens. This is rotated, but it's flutes and grooves, and they're good sedimentological features of bases of turbid flow units.
Yeah.
And they give you direction of flow.
No, well that is good. Thank you.
Flutes and grooves.
So please come and gather around. I point out the view, and come up onto this. So scrunch up a bit. So and coming. Hillary's staying in the car. Yeah. Okay. Well, look what we're seeing, which is quite amazing. And Hillary, you might want to see it after we said. Is look. This whole thing plunging along. Well, first of all, we've been driving, and as we drove, there were a whole bunch of atolls all at the side of the road. It was spectacular, but we stopped, we'd never get there. But what we've got here, this is the Arabian margin here on the right. You see it folding over, all stretching way behind. That is diving down. This is the subduction zone, and it's diving underneath the Horwesina Nap, and the Horwesina Nap is diving under the ophiolite, and here is the ophiolite. And if you actually turn around behind you, this is Horwesina Nap here, but this is ophiolite there. So the contact is just here, just literally right in front of us. The contact is just here, just, you know, sort of the shadow of this pole. So yeah, this is literally the subduction zone, just here. This is going underneath these two naps. The actual this is the Arabian continental margin. This at one point was hundreds of miles away from this, which is the ophiolite, and the whole thing is, and this has gone over the top of this, but since been eroded off.
I should sit down.
The Arabian platform
See him?
is essentially in place.
Yes.
Everything else is moved.
Yes. Well, yes. So I mean, or the mechanism of the ophiolite emplacement, though, is the subducting plate dragging the margin underneath the ophiolite. So, you know, which one has stayed in the same place?
So you're saying this is a nap and this is a nap?
I'd say you've got three naps in the view. To the right of the road is the ophiolite nap. The Somal nap. Directly behind the houses and to the left of the houses is the Horwesina nap. And further left, where it's much greyer and goes massively high, that's the continental margin of Arabia. And then if you turn around, pretty much where the shadow of the telegraph pole is, there's the boundary. This is ophiolite here on the left, and that's Horwesina on the right, which is really, really amazing.
So this has been a trip filled with stellar stops every day, and this might be the best one yet. This is a subduction zone, and what we're seeing here is the Somal ophiolite. When the basin closed, we see the Horwesina Nap when the basin opened is thrust up, and then we see the Permian platform behind it, and this is the subduction is happening here. The two naps are getting dragged down underneath the platform, and the thrust sheets actually came over the platform. They've been eroded away, so this is just an exposure of the contact as exposed now after the erosion. So this is a spectacular sight to be able to see the subduction zone.
I'm just waiting for people, the last car to come over. Okay, and this is another one of these atolls, but it has a cliff face. It's a whole kilometre high, and Misht in Arabic means comb, so it's the comb mountain. So that is part of our story. But of course, the other part of our story is the archaeology. And this is actually a UNESCO Global World Heritage Site, though you wouldn't have thought it from the access road and car park. and lack of signs. But anyway, at this site there are 21 beehive tombs. These are prehistoric burial structures built of dry stacked stones in a round dome shape. It is likely that these burial structures contained multiple individuals. The tombs date back to the early Bronze Age, around 3000 to 2000 BC, the Hafit and Nar cultural periods. The tombs are remarkably well preserved for their age, and they are one important cluster of tombs amongst an extensive necropolises in the area. So there are other sites, and I'm taking you to this one because of the atoll behind it. Together, these form one of the most complete ensemblages of Bronze Age settlements and burial monuments anywhere in the world. Because of this exceptional preservation, the site was inscribed a UNESCO World Heritage Site in 1988, called the Archaeological Sites of Bat al-Kahumt and Alain. And Jebel Misht is a striking distinctive peak, as I said, a near vertical face of 1,000 meters, and yeah, I don't really need to say much else because I've told you all to you before, but Jebel Misht is the Habi Nap. So thrusting over Jebel Misht is the Ophiolite, and Jebel Misht is thrusting over the Horwesina, and we're standing on a Horwesina, and the tombs have been made from Horwesina. But behind us is yet another exotic, another atoll back there on the top, that huge mountain there. But anyway, we were going to walk up self-guided, just go up, explore around, and we're going to drive away at 4:25. I just was reminding the new arrivals, the mountain you're looking at before is an atoll.
So this is quite a highlight to be at Jebel Misht, to see the 21 Bronze Age tombs. Adds an archaeological uplift to an incredible geological site, which consists of the Horwesina Nap, which is the flaggy stones, sandstones, that the tombs are built on. But that nap is thrust, and on top of it there is another nap that contains the atolls from the sea floor that was thrust up as well. And on top of that, not here, but in the distance, are the ophiolites. So 3 layers of thrusting, and it's quite spectacular.